Hey, sixth graders. Welcome to Thursday. So as you know, I was unable to meet with you to do our science live today. So we are going to do our science in this video together. So we have an article here called The Cardiovascular System and Exercise. We had read an article last week about our heart rate and exercise and if we should exercise when we're sick. And that's where we were first introduced about heart rate. So now we're going to look at our cardiovascular system. So yesterday we were talking about parts of our system with our veins and our arteries. And now we're going to expand on the system, the cardiovascular system, and what happens when we exercise. So we're going to read this article together. And then we have our cause and effect right below. Cause and effect. So we'll be filling out 4 causes and their effects when we're done with our article. So if you have this printed out, we are going to be highlighting and underlining as we move along. So I'm going to use my markup so that I can highlight in Cami as I'm going through it. Your muscles produce more energy when you exercise, and the circulatory system activities during exercise enhances the supply of fluids, oxygen, and nutrients your muscles need for energy production. Exercising also increases your body's rate of various chemical reactions. The circulatory system works hard in helping your body to balance and maintain healthy chemical concentrations during exercise. Regular physical activity helps increase the efficiency of the circulation system activity during exercise. So your circulatory system is the circulation within your body, okay, so that you don't get swollen or that you're getting nice airflow through the entire body so your muscles can breathe and work to their best rate. So let's talk about the carbon dioxide expulsion. Your muscles produce more energy as skeletal movements and contractions increase during exercise. Carbon dioxide is a toxic byproduct of energy production in your muscles. Your circulation system has chemoreceptors that detect changes in oxygen and carbon dioxide concentrations in your blood. Chemoreceptors send signals to your brain that increase your respiration rate when they detect rising carbon dioxide levels. Your circulatory system veins work harder circulating waste-rich blood back to your heart during exercise. Your heart contracts and pushes the blood into the pulmonary artery, which we learned yesterday, and your lungs absorb carbon dioxide from the pulmonary artery and expel the toxic gas from your body each time you exhale. Okay, so a lot of information here. Let's go ahead and underline because we're also looking for causes and effects. So I'm going to highlight and underline. Let's see. We know that carbon dioxide is a toxic byproduct, okay? We know it is expelled through our bodies and that actually plants need carbon dioxide to live. So, but what we need is oxygen and we expel carbon dioxide. So it says chemoreceptors send signals, so I want to highlight this, that increase your respiration rate. That's your breathing, right? What is the word called? It has to do with respiration. And now I can't remember it. That's okay. When they detect rising carbon dioxide levels. So I want to highlight that. Okay, your circulatory system veins work harder circulating waste-rich blood back to your heart during exercise. Your heart contracts and pushes the blood into the pulmonary artery, and your lungs absorb carbon dioxide from the pulmonary artery. I want to highlight that. And expel toxic gas from your body each time you exhale. Whoops, wrong way. No, down. There we go. Okay, oxygen intake. Oxygen demands increase during exercise because your muscles use oxygen to produce energy, which we know that we breathe heavy when we exercise, right? And energy production increases during exercise, which again makes sense because as you exercise, you need more energy. Oxygen also cools and prevents overheating as your body temperature rises during exercise. So that's good to know. I'm going to go ahead and highlight that. Your breathing rate increases and your lungs take in more oxygen with each breath while exercising. Your lungs deposit oxygen into your bloodstream, and the oxygen-rich blood returns to your heart. The heart contracts to push the oxygen-rich blood to organs and tissues throughout your body. So as you breathe in and you fill your bloodstream with the oxygen from your increased heart rate, that then fuels your tissues and other bodies. So let's go ahead and highlight that. Blood flow. Rising carbon dioxide levels in oxygen demands force your heart to contract more frequently. Okay, so this is a cause and effect right here, so I'm going to highlight it. Rising, we have others that we've highlighted as well, but this one stood out to me most. Rising carbon dioxide levels in oxygen demands force your heart to contract more frequently, which increases your heart rate during exercise. Blood flow increases as your heart pumps more oxygen and nutrients through your circulatory system, systemic portion. The systemic circulatory system includes blood vessels that deliver oxygen and nutrient-rich blood to tissues throughout your body. Blood flows forcefully through your arteries and into capillaries, which release oxygen and nutrients into tissue cells. Waste products are collected by blood that flows into your veins. Your kidneys filter waste out of the blood, and the liver removes blood sugars before the blood finally flows back through the pulmonary artery and collects oxygen from your lungs again. So it's kind of like the system and how it all works. Nutrient routing. Your circulatory system always tries to work efficiently, particularly during exercise. Working muscles becomes your circulatory system's top priority during exercise. The system restricts blood flowing to tissues and organs not working as hard, particularly your digestive organs. More resources are diverted to your skeletal muscles. Capillary beds in your muscles expand and deliver more than 12 times as much blood to working muscles during exercise. Wow, so I'm going to highlight that. That's interesting. Capillary beds in your muscles expand and deliver more blood. Your blood pressure increases during exercise because greater amounts of nutrient-rich blood flowing through your circulatory system increase pressure inside the blood vessels. So I'm going to highlight that too. Okay, so we have some good highlights here, and I think a lot of these highlights produce cause and effect. A main cause would be exercise. Okay, so let's go back through our highlights and see what we're going to write down for our first cause. So I'm going to start here, carbon dioxide expulsion. So chemoreceptors send signals to your brain that increase your respiration rate when they detect rising carbon dioxide levels. So the cause is your carbon dioxide levels rise, and the effect is your chemoreceptors send signals to your brain to increase your respiration rate, which is your breathing rate. Okay, so let's go ahead and put that. I'm going to go back down here to cause, use my text box. So let's go ahead and put that as carbon dioxide levels rise in your body, and the effect is chemoreceptors send signals to your brain. And I actually need to go back up because I don't remember. To your brain to increase your respiration rate. To increase your respiration rate. Oh, I did not. Oh, let's see. Yeah. Okay, there's one cause and one effect. So let's go back to our other highlights and see what other causes and effects we can find. Let's see. Your lungs absorb carbon dioxide from the pulmonary artery and expel the toxic gas from your body each time you exhale. So we could do that one. Your lungs already had a brain fart. Now I have to go back. Your lungs absorb carbon dioxide. And what is the effect of absorbing the carbon dioxide? Let's go back up. Then your lungs expel the toxic gas every time you exhale. So after it absorbs, the effect is that it as you exhale, your lungs expel the carbon dioxide. Okay, so now let's go to cause number 3. Let's see, oxygen intake. Oxygen also cools and prevents overheating as your body temperature rises during exercise. So your body temperature rises is the cause. The effect is the oxygen cools your body and prevents overheating. So sorry, let me do that again. Your body temperature rises. Your body temperature rises during exercise, and the effect is oxygen cools and prevents overheating. Okay, now let's move on. The heart contracts to push the oxygen-rich blood to organs and tissues throughout your body. Okay, blood flow. Rising carbon dioxide levels and oxygen demands force your heart to contract more frequently, which increases your heart rate during exercise. Okay, so higher levels of carbon dioxide and oxygen, and the effect is that your heart contracts more, which increases your heart rate. Okay, so higher levels of, I can't spell today, carbon dioxide and oxygen in your body. When you have higher levels of carbon dioxide and oxygen in your body, it forces your heart rate to increase. And let me see what else it said. Where is it? Heart rate increase and your heart to contract more frequently. That's what it was. Forces your heart rate to increase by your heart contracting more frequently. Okay, so we actually have all 4, so we are good, but just to continue, there's more here. and right here too, rising. Oh, I just did that one. Ha 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 ha. So, but we got the gist of it and we filled out our 4, so we are good. And hopefully you are learning more about your cardiovascular slash circulatory system, because your circulatory system is what allows the oxygen to flow through your body to help out those organs and tissues that need it most, especially during exercise. So, all right, if you have any questions, Google chat me, and I will see you guys soon. Bye.